Okay, so let's take a look at another example. In this example, we're going to have repeated eigenvalues. So we have to find the general solution of the system. And our system here is x prime equal to negative 12x plus 7y, and y prime equal to negative 7x plus 2y. Okay, so our first step will be to write the system in matrix form. So let's do that. Okay, so I've written it here in matrix form. And again, how you get the matrix form is you take the coefficient in front of the x in the first equation, so the negative 12. That goes here. 7 in front of the y, it's going to go here. The negative 7 in front of the x down here goes here. 2 in front of the y goes here. Then you put the xy on the outside and the x prime, y prime over here. Okay, so that's the matrix form. Now let's look at step 2. So for step 2, we're going to find the eigenvalues. So let's do that. Okay, so to find the eigenvalues, we're going to look at the determinant of this matrix here. And that matrix I got from our matrix on top by subtracting, so it'd be negative 12 minus lambda here and 2 minus lambda here. Okay, so taking the determinant of the matrix, we're going to go the negative 12 lambda times negative 12 minus lambda times 2 minus lambda. Then we're going to go 7 times minus 7. I'm going to minus down there. And that's how I got this guy here. Then multiplying this out, we'll have our negative lambda times negative lambda. Gives me a lambda squared here. Then we'll have negative 12 times negative lambda be 12 lambda, then minus 2 lambda. So give me the 10 lambda here. And then minus 12 times minus 2 be minus 24. Then minus 7 times minus 7 with another minus in front, we give us plus 49. And that reduces to lambda squared plus 10 lambda plus 25 equals 0. And that guy you can check factors as lambda plus 5 squared equals 0. So we set the lambda plus 5 equal to 0, and we get that lambda equals negative 5. Note here, there's just one eigenvalue. It's repeated because we have the lambda plus 5 squared. It's like a multiplicity 2. Okay, so now let's look at the next step, step 3. We want to find the eigenvector corresponding to lambda equals negative 5. So let's do that. Okay, so now to find the eigenvector corresponding to lambda equals negative 5, we're going to, let me just raise this guy up here, this stuff up here. We're going to put negative 5 in place of lambda here and here. And that's how I got this guy down here. And we're going to solve this augmented matrix to find our eigenvector. So it's going to be set equal to 0, 0 over here. Okay, so negative 12 minus a minus 5 will be minus 7. I'll have our 7 there, then minus 7 there, and minus 2 minus a minus 5 is 7 there also. So then we're going to want to make a 0 in that position. So if we go row 1 minus row 2 to give a new, should be row 2 here actually. Yeah, just change that. A new row 2. So doing that, we'll get a negative 7 plus 7 to be 0. So here, and then 7 minus 7, 0, 0. And the minus 7 here is in the K1 column. and the 7 is in the K2 column. So now we can use back substitution to solve. So let's do that. Okay, so let me just erase this stuff over here. Okay, so using a back substitution, we'll have our -7 K1, which I'll put here, plus 7 K2 equals 0. And then solving for K1, you'll have then K1 would equal K2. And K2 is free here, so you can choose, say, K2 to be 1. Then if you put 1 in place of K2 here, that means K1 would be 1. So eigenvector will be the K1, K2. So it's going to be 1, 1 in our case. And then our solution that corresponds to this eigenvector will be our V1 here. So it's going to be our eigenvector, so 1, 1, e to the lambda t, but here our lambda is -5. So that's one solution. So since there's only one eigenvalue, we cannot find another eigenvector. So the question is, how can we find a second solution? So let me explain that now. Okay, so in general, when lambda is a repeated root with only one solution, like we have in our case here, a second solution is given by V2 equal to K1, K2, T e to lambda T plus P1, P2 e to lambda T, where we have our A11 minus lambda, A2, A21, A22 minus lambda, P1, P2 equals K1, K2. So let's see how we can apply this to our example here. So let's do that. Okay, recall, we go back and check there our A matrix at the beginning. So our matrix at the beginning was -12, 7, -7, 2. Okay, so when you're using this formula here, we'll have A1 minus lambda, A2, A12, A21, A22 minus lambda. In our case, then it'll be our lambda is -5. So you're going to go then our -12 minus our lambda. So I got this guy. So minus and -5, then our 7, -7, and then our 2 minus our lambda, which is -5. And when I set that equal to our, so set it equal to your K1, K2, that's your eigenvector. In our case, our eigenvector was 1, 1. Okay, so we have to solve for P1 and P2 now. So let me explain how to do that. Okay, so to find a P1 and P2, we're going to have to solve this augmented matrix. So the augmented matrix is pretty much just the entries in this matrix here. So -12 minus -5 would be -12 plus 5, -7 there. So I got that one over there. That'll be our 7. Then our -7. That'll be -2 minus -5. So that's going to be 7 also. Then this vector over here, you're going to put here. Okay, so you want to make a 0 in this position here. So we're going to go row 1 minus row 2 to give a new row 2. Okay, so I'm going to subtract these two. So we get a 0 in this position, 0 here. And then 7 minus 7 will be 0 here. And 1 minus 1 will be 0 here. And now we can use back substitution to solve, because this is the P1 column. This is the P2 column. So this is saying then, translating to an equation, let's say -7 P1. So that's how I got this guy here. plus 7p2 equals 1, then you could solve this for p2. So add 7p1 to both sides and divide by 7. And that's how I got p2 is equal to this. And then p1 now is free. So I'm going to let p1 equal 1. So letting p1 equal 1 then, we'll end up with my p2 equals 1 plus 7 over 7. So 8 over 7 is my p2. Okay, so now we found the p1 and p2. Let's keep going. Okay, so now we can write our solutions. So we can use, let me erase some things here. Stuff here. Now we can use up here, our v2 now will be equal to this. So it'll be our 1 t e to the negative 5t, and p1 p2 e to the negative 5t. And our p1 was 1 and our p2 is 8/7. Okay, so that's how I got this done. Then I can factor out the e's here and here. So factor. Out. So that's what I've done over here, put it on the outside. And we can write a solution like this then. Okay, so let's keep going. So now let's actually verify that V2 is indeed a solution of our system. So recall, here's our A. So let's first look at A times V2. Okay, so my V2, let me erase this over here. My V2 is right here. So I got that. Then I can break this up. I can do so I pretty much distribute. So your matrix times your 1, 1 vector, and your matrix times your 1, 8 over 7 vector. That's what I've done here. And now let's multiply these guys out. So doing that. Okay, so let's erase a few things here. So let's first multiply this guy out here. It's going to be 1 times minus 12, then 1 times 7. So I got this over here. It's going to be 1 times minus 7 plus 1 times 2. So I got this over here. We still have the t in front, so the t is right there. Then moving on to the second matrix, we got 1 times minus 12, and then 8 over 7 times 7. When you multiply 8 over 7 times 7, the 7's cancel, just become an 8. That's how I got that. That'll be 1 times minus 7, and then 8 over 7 times 2, which would be 16 over 7. That's how I got that. Okay. Now, adding, so looking at these now. So negative 12 plus 7 is negative 5. That's how I got that. And negative 7 plus 2 is negative 5. That's how I got that. And then negative 12 plus 8 is negative 4. And here, you can write minus 7. We can write it as, straight here. So minus 7, let me just move it. You can write as negative 49 over 7. So I got that one right there. And we're adding 16 to that. And then simplifying this, the negative 5, we can pull a 5 out. So I've done there. We still have a 1, 1 left there. And then negative 49 plus 16 will be negative 33. So I got this guy here. Okay, so that's my A times V2. Okay, now let's look at the derivative of V2. Okay, so now let's look at the derivative of V2. So here's my V2 is this guy up here. So this is my V2. Okay, so we're going to have to use the product rule on it. So the so the 1 and the 1/8/7, that's the inside function, and the sorry, that's the one function, and the e to the negative 5t is the second function. So the derivative of the first function, so derivative of t is just 1 times second. So 1/8/7 is a constant, so it's going to be 0 when you take derivative. So derivative is t is 1, so there's be 1 there. And we still have the e to the minus 5t, so I get that. Then it's going to be the first function. So the first function is 1t plus 1/8/7 vector. Then derivative of my e. So derivative of e to the minus 5t. Well, derivative of minus 5t is minus 5. That's how I got that. E to the minus 5. So what I used here is a product rule. Product rule. Okay, then I can factor out the e to the minus 5t here and here. Jump it over here. And that negative 5, I multiplied in. Okay, so let's keep going. Okay, so let me just explain this a bit more. So I went negative 5 times 1 and times the 8/7. That's how I got this guy, because negative 5 times 8 would be negative 40. And then this 1 here is right there. Then it'd be negative 5 times 1t, which I've just put the negative 5 here. Okay, now we can combine these two vectors here. So erase this. We can combine these. So we're going to go negative 1 minus 5 and 1 minus 40/7. And 1 here you can write as 7/7. That's what I've done here. And so doing that subtraction, then the 7/7 minus 40/7 will give us the minus 33/7, and 1 minus 5 will give us the minus 4. And we still have this. And comparing this, the derivative of V2 now, with a V2, you can see they're the same. These guys here are the same. So they're the same there. So hence we've shown that a V2 equals V2 prime. And that's what it means to be a solution. So let me write that. Okay, so hence we've shown then that a V2 equals V2 prime. And that's what it means to be a solution. So we've shown that V2 is a solution of our system. So now let's write the general solution. Okay, so our general solution then will be CB1 plus CB2. And our V1 was the 1 e to the minus V2. And our V2 was 1 e to the minus 5t plus 1/8/7 e to the minus 5t. We can then factor out the e to the minus 5t here, and here. So I've done over here. And we can write it a bit simpler as this. So this guy here. All right, so we're done with the question. So we found a general solution. Okay, so let's leave it there.